Hello and welcome everyone. I'm your host Stefan Burns, geologist, geophysicist, space weather guy, here with a big comprehensive update for you. Really an investigative report. I'm just a third-party guy who finds what's happening on the planet and the natural processes of the Earth interesting. I started doing a deep dive into all this a few years ago, though, I've been interested in natural and earth sciences since I was a kid. So it's really just always been a natural evolution, progression, learning more and more and more. Was able to, not was able to, I took a leap of faith and quit my job back in 2021 so I could do deep research on all these things that fascinated and interested me. And well, I'm constantly learning new things, and I'm sharing that all with you here on the YouTube channel, which is why this channel has done fairly well, because you guys appreciate not only the up-to-date information on what's happening with the Earth. Case in point, we just had a magnitude 6.6 earthquake strike the central Atlantic along this mid-ocean ridge system. This was on the transform fault, actually the largest section of this transform fault. But this is where the plates are spreading apart. It's a divergent plate boundary. We cover up-to-date things like that are happening. We are going to be looking at the recent activity as it relates to earthquakes, because we've been in a seismic burst globally now for the past few days. And this all is following up after the magnitude 7.8 earthquake that struck the Philippines on the 7th of June. I believe it was the 8th local time, but it was right at the very end of the day, June 7th, as it relates to universal time. But I also, simply just educate you on earth science and space and the sun and much more than that. But there are unprecedented changes that are unfolding here on this planet. And I try to look at it from as open of a perspective as possible, and also as multifaceted as possible. Because unfortunately, with today's society and just in general, I think there's so many things that are on people's minds that it's difficult to maintain an open perspective because it's simply too much bandwidth. So it's easier to just lock into a tribal opinion, for example. And I'm not saying it's good or bad. In general, I think seeing more of the truth is a good thing. But I'm not condemning this. I think it's just simply a consequence of kind of where we are societally and, overstimulation and all these things. It's a whole topic in and of itself. But as it relates to what's happening with the Earth, right, it's very multifaceted. It's a very nuanced story. And it's not just, oh, we're about to enter into an ice age, or, oh, the Earth is warming because of CO2. Like, it's across the entire board. There's a whole bunch of things. So in this video, we are going to go into all those things, because there's some indications that we have some really big events ahead of us. And it may not necessarily just be Earth events. It could also be solar events. Longtime viewers and even short-time viewers of the channel know that we look at the connection between the Earth, the moon, the sun, the planets, the stars. They're all much more interconnected than a lot of people realize. Of course, everything in the universe springs forth from the same universal substance, so there is this inherent connection built into reality. Though there are forces that are working to make you forget this or to lose your connection to this. Keep that in mind. But we see these connections time and time again. Case in point, this magnitude 6.6 earthquake today. We had a rare occultation of Venus by the moon today. Here we see that I took this photo myself. So it's about 11-12% waxing crescent moon. We just had the new moon on the 14th. We had Kilauea volcano on the Big Island, Hawaii erupt for the 49th time. When that happened, some crazy tornado volcano stuff was happening then. That volcano is synchronized to the fortnightly tidal rhythm, which is that full moon, new moon, strongest tides. That research goes way back. So really interesting that we had this historic record-breaking 49th Fountain episode at Kilauea right as we had the new moon. Well, now it's the 17th, so the moon's moved a little bit ahead. Now it's a waxing crescent. And in fact, it moved right over Venus. So actually the direction of motion was this way because the sun was off this direction. You see the sunlight right there. You know, this isn't a super high quality photo. It was just taken with my phone. But the moon moved directly over Venus, occluding it. And then we see here the moon just after it finished its occlusion. So last time this occurred was December of 2015. So it's been like 10, 11 years. Well, within an hour of this rare celestial alignment, we had this magnitude 6.6 earthquake right there. And that occurred right as the sun was going down in that location. So it was right on the limb of the earth. If you have the sun in front and you have the earth right here, it was exactly on the limb, square angle to that. And then 38 degrees skew on the daylight side, you had Venus and the moon in a perfect alignment. So you see these sort of connections in time because, well, this isn't just one magnitude 6 of 10 that have occurred today or 20, whatever. This is by far the strongest earthquake that we've had today at a magnitude 6.6. And it's a very strong earthquake for a divergent plate boundary. Typically, they're not magnitude 6.5 or greater. You can get up to magnitude 7, very rare. Very rare. You almost never see magnitude 7 earthquakes on a spreading center or one of the transform fault that connects them. The transform faults here where they slide past each other is red. Green is where the plates are actually being created. You have this convection from the mantle generating new oceanic plate. You know, there's magma bubbling up and creating pillow basalts and more. So this is a very notable earthquake. And it follows up just about a little more than 24 hours after we had a sequence that struck in the Western Pacific and basically Asia. So we can see that, I think, where do I have to click this on? We should be able to see all of these. I'm just not seeing the, oh, there's the China one. Okay, yeah, it's just hidden from me. So we see this magnitude 7.8 and also its strongest aftershock magnitude 6.5 there that occurred on June 7th, June 8th. We also had this 6.7 that struck Indonesia on the 16th. This was an extensional earthquake. So you actually had the earth extending out a little bit. It's a normal fault. So one side went down, whereas with this bigger quake, it was reverse thrust. So it thrust upwards. Well, on that same day, on the 16th, we also had this magnitude 6.3 here in China. This was a combination of strike slip motion and also a bit of reverse movement. So it was an oblique thrust. Both of those occurring on the same day. Well, now the 17th, we have this magnitude 6.6. So we are in a classic global seismic burst. And on the 16th, yesterday, when both these earthquakes popped off, that's exactly when our solar wind was in a state that we've identified to be well correlated with there being heightened global seismic activity. Namely, the solar wind density is low. You're in a high-speed stream or you're still in that high-speed stream structure before something else comes in. I'll explain that all. But we see that we've had these earthquakes here. And if we go over to their antipodes, which is the opposite side of the Earth, and we also add in that 7.8, this is the one for China because it's the furthest afield, but we see that their antipode area almost exactly is centered right where we had the magnitude 6.9 that struck on the 25th of May. And you see it's exactly centered over this bend in the Peru-Chile subduction trench. And typically when you get a bend in a fault, it can build up to have bigger earthquakes, but they're less frequent. Now the magnitude 9.5, the strongest ever recorded, 1960 Great Chilean earthquake, there is the epicenter for that. And you see that, you know, you have this subduction trench, but look, it's not all that strong right here. I mean, compared to up north, look how much deeper it is. And also look at the Andes. The Andes are crazy where that bend is. Like, you don't get mountains generated unless you have over time a lot of uplift, right? Big big reverse thrust earthquakes pushing the land up. So we see this strongest earthquake ever. Yeah, it occurred in a subduction zone, but it's not really that crazy looking. Meanwhile, it slipped hundreds of miles of fault and was shaking for like, I think it was like 5-10 minutes. I mean, literally insane how strong this earthquake was. So, you know, this section of fault should be able to have even bigger earthquakes, theoretically. But this is what we see, the biggest on record, 6.5. Well, we're seeing unprecedented changes with our planet since 1960. Of course, back in the 40s, 50s, 60s, we had tons of nuclear bombs that we exploded. Thousands of nuclear bombs exploded across our planet. That obviously has an effect on the geology, the geophysics. Millions have died from that as a result of radiation that was swirling around the globe, cancers, things of this nature. You notice how they never talk about that. It's one of, if not the greatest crimes ever committed, because also, how did that affect the Earth geologically? There is a resonance. If you look at the waveforms and the data, there's a resonance between nuclear bombs and earthquakes. What that means is that they're very similar in their energetic expression. And with resonance, one tuning fork, you hit the other, they both vibrate, right? Well, you had two massive magnitude 9+ earthquakes, 1960, 1964. That's 9.5 Chile, 1960. Magnitude 9.2 Alaska, 1964. The Tsar bomb, the biggest ever, was dropped 1962, smack dab in the middle. Hundreds, if not thousands, of nuclear tests on either side of that. We know that the total is thousands of nuclear tests. That was unprecedented, but we've gone even further than that now. Now, because of a combination of natural and anthropogenic factors, our Earth is changing faster than we've ever observed in the geologic record. Now, keep in mind, there's been some big things that have happened in geologic record. I'd say probably the fastest change that's ever happened is a giant impact, because that's like within 10 minutes that thing's coming in and boom, the impact happens. So we have that. We know that these things also can occur. That is faster. And the last mass extinction, KT, Chicxulub impact, boom, Yucatan Peninsula, that's obviously a big deal. We find evidence for like snowball Earth and all these other things, massive flood basalts that over millions of years cause mass extinctions, global climate changes, and more. But in terms of how fast the planet is warming right now, that's really unprecedented. Short of something beyond, literally beyond imagination, like an impact, okay? And it's a fairly simple equation. We'll talk about it. You know, it can be simple, but it's also obviously very complex. But if you boil it down, it's fairly simple. And it's not political. I don't know why geology or climate or any of this stuff has turned political, right? It's the Earth. I just want to understand what's happening. Because this is our one planet. We have one planet, one home in this solar system, in this galaxy. Eventually that may change, but we are blessed with this planet that we have. Mars is not going to be that fun, folks. Except the fact that the gravity is going to be less, and you're going to be able to jump around a little higher. Mars is not going to be that fun. The moon is not going to be that fun. There's really nowhere else in the solar system that's like the Earth. And we got it made here, okay? And then what? You go to the next closest star system, Alpha Centauri, Proxima, or A and B. Like, we don't know what their planets are like, Goldilocks zones, whatever. Bernard star, Sirius, like, that's 10 light years away. Alpha Centauri's 5 light years away. Like, we have no technology to get there. Even getting to just the moon is difficult right now. So we can't, like, bank on that. We got one planet. We can't F it up, okay? You can't F it up. There are people that are doing that. Really arrogant people that are doing their best to F it up. So we're going to go into all that in this video. Hello and welcome. I'm your host, Stefan Burns, geologist, geophysicist, just your space guy, your cosmic bro. We have people coming in on the live stream from all over the place. So global audience here. Thank you everyone for being here. We have people from, someone from Delaware, just reading some of the comments early on. Las Vegas, Maine, Oregon, Philadelphia, Manitoba, Vancouver, BC, Alberta, New Hampshire, Florida. Tons and tons and tons of people really showing North America, California, North America really representing today. Aloha from Honolulu. Awesome stuff. Awesome stuff. So let's go into a bit more of what's happening right now. And then we're going to kind of build to the larger story, because to lay it all out in 1 minute, it's simply not possible. So we're going to do all the different sections, and then it'll kind of all come together for you cohesively. So yeah, we just had this magnitude 6.6 here, mid-Atlantic ridge, and this is a classic strike-slip earthquake on this transform fault, and this is the boundary between Africa and South America. Now you'll also notice, I think if we go over here, is this it right here? Yeah, you will notice on the other side of South America, right here is the 6.6 mid-Atlantic, other side is a 6.6 magnitude earthquake also here on a transform fault for a divergent plate center, plate boundary, and that was back on the 20th of May. So the first, and this is kind of a whole sequence of events that has unfolded for the past 30 days that's very coherent. What I mean by that, it all has these interconnected relationships with it, like I showed you with the antipodes and more. So the first event that we had in this coherent set of earthquakes is this magnitude 6.6 on a mid, on a trans, on a bit, let's just call it a mid-ocean ridge, even though this is specifically the transform fault part of it. It's just simple to call it a mid-ocean ridge. And then the most recent event is also this 6.6 mid-ocean ridge, okay? Well, then afterwards, we had a magnitude 6.9 earthquake that struck here. This is, oh, that's a magnitude 6. There is a magnitude 6 that struck. Yeah, here's where the magnitude 6.9 struck near, what is it? It's Calama, Chile. And this is fairly close to the bend. And this one did have some aftershocks, as you can see. If I just put this on here, we see that we did have aftershocks, but the strongest was a 5.1. And typically, the strongest aftershock you'll get will be 1 magnitude less than the main shock. So we'd expect about magnitude 5.9 or magnitude 6 aftershock. We didn't get it. We got 4.7, 5.1, really kind of anomalous. Now, following up after this 6.9, we then go over, okay, to the 7.8 that struck. And there's been a huge swarm of earthquakes here in the Philippines. This is southern Philippines. And if we set this for largest magnitude, 7.8, 6.5, 3 other magnitude 6 plus earthquakes, tons of magnitude 5s. Look at this. This list is still going. And then, of course, 4s, 3s, 2s, and 1s. So just what we're seeing on the map here is showing 96 earthquakes and what's this, a 6.2? Yeah, so some of the aftershocks are a little further afield, but we got about 100 earthquakes here on the map view right now, but hundreds of earthquakes have popped off since that 7.8, and then just about less than 10 days later, we have this magnitude 6.7 hit Sulawesi, Indonesia. This also having some aftershocks, but we see the strongest thus far is a 5.2. We're still just a little bit more than a day afterwards, so we could still get something like a 5.7 or 5.8, let's say, to pop off. But as of right now, 5.2 is the strongest. And then just shortly after that, we had China pop off with a 6.3, and that also had a swarm to it, though not as much. Here we see our 6.3. Here we see a 5.4, 5.2, 5.2, 5.0. Actually, a bit of the opposite of what we've been seeing with the others without them having typical aftershock sequences, them having a deficiency there. This one that hit China has more than normal. So the 5.4 being stronger than what you'd expect at 5.3, though it's in range. But then you also have a 5.2, 5.2, 5.0. So this is a bit odd, and you can get big earthquakes in this part of the globe. We've had magnitude 8 earthquakes in Mongolia in the past, like 100 plus years ago. You can get really big earthquakes in this zone. So this isn't necessarily an indication that everything's about to get really weird, and there's going to be a really big earthquake, but the aftershock sequence is a bit anomalous. Now, going back here to Google Earth, again, if we look at these quakes, here they are on Google Earth, right? They're kind of hard to see, but there it is, there it is, there it is. If we plot their exact opposite points on the globe, we get this triangle here. That's the 6.9 that preceded them. So interesting to see the sequence there, right? That you have this magnitude 6.9 strike South America. South America hasn't had a big quake for about 18 months now. We've had tons of activity in the Western Pacific and in Asia in general. The magnitude 8.8 earthquake that struck Kamchatka. We had multiple Mag 7s that have struck Indonesia, the Philippines, Japan. So there's been tons of activity in the Western Pacific and that part of the Ring of Fire. All of this, tons of activity. We haven't really seen it bounce out as it relates to South America, the site of the strongest ever recorded earthquake, magnitude 9.5, and not even a location that you'd expect to be the biggest, this bend being that location. So South America is overdue for a megaquake, that's for sure, and this area specifically is also, I think, overdue for an earthquake. We can look at our big earthquakes for South America here. This goes back to the year 1800. It's not going to have everything because our record starts to get a little spotty once you go back. But we see our 9.5. We see an 8.8 that occurred just nearby in 2010. So that means that that area is probably ruptured and isn't due for anything big in the immediate future. We could see, but 50 years later, a 8.8 ruptures, a huge earthquake, we're probably good. And I think we can actually look at the fault trace. Yeah, here it is. Look at the rupture on this for the 9.5. That's the epicenter, but they determined that it ruptured all the way down to the triple junction here. And there's your scale bar. So we're talking probably 600 miles right there. I mean, about 1,000 kilometers. Huge, huge, huge rupture. Ground shaking for 5-10 minutes, really gnarly stuff. But if you go back here and we zoom in, like we really zoom in on this bend, here's an 8.4 near the top of it, 8.2 right there in the center, 2014, 8.0 near the bottom there. Do you see that, right? But we don't have a magnitude 9 or anything in our record for that location. And that's where you're going to get the biggest. I mean, look here. You can even see just the texture on the mountains, the Andes going into the Amazon of just all that compression, right? Because the land is uplifting here. It's literally uplifting. We just saw that with the magnitude 7.8. Check this out. We had this huge uplift from the quake that struck the Philippines. So here it is. You see there before the earthquake struck, you had the water going right up to that little village there, that little fishing village, let's call it. And you have the reefs offshore. And then you see that after the earthquake, the shoreline expanded by nearly 200 meters. And that's been verified by many people, local organizations, and more. But huge, huge, huge uplift of about 2 meters for the southern part of the Philippines near the epicenter of that quake because, again, the land thrust up. So this is a 7.8, right? You get a really big earthquake, right? It really raises it up. And, well, if we go back here, how do you think the Andes, one of the tallest mountain chains in the world, how do you think they got their height? Well, they did it over time, over millennia, eons, millions of years. Each earthquake slowly building it up, and there's also just a gradual increase that exists. But we've probably had earthquakes bigger than 9.5 there. Now, just a little bit of a reference point for you, okay? We'll go back to our normal graph. a bit of a reference point for you is that we can use California. Now this is different fault dynamic. This is strike slip where they're going past each other. It's not a subduction zone. It used to be off California a few million years ago. Now it's not. But the biggest earthquakes that have struck San Francisco 1906 and then Fort Tejon in 1857, they occurred near the bends. So you see these two bends in the San Andreas here, like that. That's the first bend to the north, and you see the second bend further south. And this is where the stress builds up the most. And so those big earthquakes occur in locations where then that fault can finally rupture and move. So you get magnitude 7.9s. And we are going to talk a little bit later about California, how the potential earthquake magnitudes there actually may be more than magnitude 8. Because there is something unprecedented that's happening for California that I've never really heard anyone talk about. I don't know the level of effect of this. It may be very significant. It may just be a minor force that really we can ignore, but it is unprecedented on the geologic timescale. And I have a feeling that the earthquake magnitudes could actually be around probably 8.5 for California at their maximum. So, you know, when they're building things, they're taking into account magnitude 8. So they're not engineering California resident buildings and stuff like Tokyo, where they're worried about magnitude 9s and greater. So we'll talk about that in a little bit. But this is a good example of how these bends in major plate boundaries have the potential for the strongest earthquakes because that stress builds up. It's just the geometry, the simple geometry of the plate boundary / fault is such that it takes more for it to finally slip. The stress can accumulate greater because it's like, you have two jigsaw pieces connected together and you're trying to move one past the other, right? Well, if there's two flat edges, easy to do so. But if you have the other one locked inside, you're going to have to put a little bit of force off that and you're going to have to rip it off basically to get them to move. So that's the deal. It's fairly simple. Well, look at this. And why even have that? Why even have that in the first place, right? Like, why does South America need to have this bend in its subduction zone? Like, why? Why not just have the subduction zone be straight? Like, we don't know. I don't know the answer to that. But clearly, we have something big there. You also have, of course, the hot spot going off to Easter Island. So that's all implicating connected to this. The connection between earthquakes, volcanoes, and more is really profound. They're connected to the moon. Tidal rhythms. The Earth right now is speeding up with its spin. And it's not just because of the moon. Actually, typically the moon slows down the Earth. So something now to add in is that Earth's rotation is speeding up. We'll read this article here from Discover. So in the 1950s, scientists invented atomic clocks. They measure effectively like the jiggle, the vibration of a cesium atom, and they use this now to very accurately track the rotation speed, the spin of Earth on its spin axis. They use it to measure that. So the overall trend is towards longer days because you have what you have happening is the moon is slowly moving away from the Earth in its orbit, and it's taking angular momentum away from the Earth. So the moon used to be closer, and Earth used to actually spin a lot faster. Like there's some estimates from early on that the Earth was spinning like every 6 hours, like one rotation every 6 hours. You can imagine how crazy the tides would be, how crazy the earthquakes would be, all the volcanic activity, wild. So the moon is stealing a little bit of energy, angular momentum specifically, from the Earth all the time, and Earth is slowly rotating just a little bit slower than normal. Well, right now, Earth is actually speeding up a little bit, and this is due to a variety of factors. You have changes in the rotation speed of the inner and outer core that influences this, but you also have changes occurring in the surface of the Earth, for example, the atmosphere and also water and ice, that are able to influence this rotation by about like a millisecond, or or in the millisecond range. We see that here, the average day during the Roman Empire was about 40 milliseconds shorter than it is today. And that's because of, that lunar influence was less back then. Now it's a little bit more. And also there's other variations like we're talking about. But you have the Earth actually speeding up at this moment in time. And another interesting thing that occurred is that we had our Chandler wobble effectively disappear in the 2010s, and it's just now starting to come back. We don't know what's going to do going forward, but the Chandler wobble, which is this free oscillation of the Earth on its spin axis of about 433 days, right? It's just a natural resonant oscillation of the Earth to kind of wobble on its axis every 433 days. It disappeared. Now there's also an annual wobble. Together, the overall motion that can be away from the idealized spin axis can be like 10 meters. But we see that Chandler wobble went extinct in the 2010s. Now it's starting to come back. And these changes actually you see start to go back to around the late 1990s, where you get this reduction in the amplitude. Then it really went away. We don't know where it's going to go. I mean, maybe it re-strengthens back to normal. Maybe it stays flatlined or reduced 50%. We see here also, and these are the different components, okay? So we have the X and the Y component here. You see how the annual wobble change as a result because they construct and deconstruct. So sometimes Earth is having this big swing out in its wobble like this, and other times it gets close and speeds up, and then it swings out and speeds up at this like roughly decadal frequency. See that? That's where the overall, it's a little spinning faster and not as wobbling as much because of the two interacting together. But we see that the overall wobble became just in general more homogeneous during this time frame. But that's a big change. Last time we saw something like that and it wasn't as severe was in 1925 to 1940. So these are like significant Earth changes. Now, this is related to the movement of atmospheric circulation. We know that the atmosphere is able to exert an influence over Earth's angular momentum. That's really interesting. The atmosphere is a big player in this whole system, obviously. And of course, the atmosphere is what connects us to the space environment. So you have these effects that go in from the sun via the space environment to then us. So we know that the sun is a big player. We see with these big coronal holes on the sun, how they influence earthquake activity, modulated through the atmosphere and more. So it's all this super interconnected system. I mean, I could sit here for 20 hours and talk about this, and maybe I do an epic live stream one day and do that. But it's all interconnected. We have, at this moment in time also, a modern maximum of solar activity. So I can just kind of show you this really quick, but let's get this pulled up. Here's our modern maximum of solar activity. So you see all these solar cycles there. Well, back from 1645 to 1715, we had the modern minimum. We had no sunspots. Solar activity is basically non-existent for, what would that be, about 70 years? 1945 to 1715. Right? Long time. Very long time. About 70 years. Now we've been having a lot of solar activity. Strong solar cycles. Solar cycle 3 right here. Very strong. Solar cycle 19. Very strong. That's loading the Earth with a ton of energy. During this time frame, we've also changed the atmospheric composition quite a lot. Right? We've basically taken a whole bunch of sequestered sunlight, which are hydrocarbons, over millions of years. The sun's always shining, folks. Thank God for the sun. Sun is always shining. Plants are looking up. They're photosynthesizing. They're having a good time. Some of them get sequestered geologically, and plant matter, all that carbon, converts into hydrocarbons. Hydro, water. So you have then this long chain of oxygen, hydrogen, and carbon that you can If you have a little match, thank you Prometheus, if you have a match, you can light on fire and kaboom, because it has latent potential energy to it. But when it's just chilling there, there's nothing to worry about. You're filling up your car and you get a little gas on your hand. Well, so long as you don't like light up a cigarette or something, you're going to be fine, right? But you want to make sure you wash your hands off. But it's not like you all of a sudden light it, like get incinerated or something, because it's inert and stable at room temperature. So it's sequestered sunlight, sequestered energy. Think of how much energy the sun's always emitting. And over millions of years, how much that energy has been sequestered into hydrocarbons. Well, starting in the 1850s in Pennsylvania, oh wow, look at this black gold that's gushing out. Maybe we can do something with it. We don't have to kill the whales anymore, right? We've taken millions of years of sequestered sunlight and we've lit that match. And as a result, first and foremost, you're releasing energy into the environment. It was sequestered before, now it's been released. A lot of that energy radiates out as long wave radiation, but we also know that there is a radiation imbalance. So there is more energy right now, this infrared energy, right? This is heat energy being contained within the earth and is radiating out. But we simply, because of human activity, right, in addition to the solar maximum modern cycle that I've talked about, there's natural forces and then there are anthropogenic forces. Of course, we are a product of nature, but we made this decision to unlock the energy of millions of years of solar sequestration in an instant. Everyone that's driving a car basically has like a campfire, right, in front of them. You put your hand on the hood, it's hot. It's releasing heat. Now, in addition to that, it's just simply making the environment hotter. You're running your air conditioner. Well, guess what? Your house may be cold, but your outside environment now is even hotter than it was before. So it's like this trade-off. In addition to that, you're releasing carbon dioxide into the atmosphere and you're releasing water vapor. Now, water vapor, these are both greenhouse gases. They help heat get stored in. So heat that normally would be radiating out, instead it gets reflected back down. And it's just a small amount, but over time it compounds. So a lot of people talk about carbon dioxide. A lot of people think carbon dioxide is a scam. It is simple science. It's become political. I don't know why. Don't ask me why. It's so dumb. And on the other side too, where the carbon dioxide freaks think that the sun doesn't have an influence on Earth's climate. That's also equally dumb in my mind. But you have carbon dioxide having a greenhouse gas effect. Even more so is water. Water vapor has a tremendous greenhouse gas effect. It is the primary greenhouse gas. And now also you have these changes to atmospheric circulation. And well, that's influencing the angular momentum of the Earth. Right? Now you can have that wobble start to change. And if we go back to our wobble right here, right? Well, when did the last big earthquake occur? Magnitude 9.1, Japan, 2011, right? All in this zone. Also, the magnitude 8.8 Kamchatka, 2025. Also, when the wobble starting to get weak. So we've had two big earthquakes during this period of reduced wobble. That I don't know how well those are connected to that, but it's certainly interesting timing, especially the 2011 magnitude 9.1. Very interesting timing. But both of those helping the Earth just retain more heat energy. And then as global temperature goes up, you can hold on to more water vapor in the atmosphere in the first place, about 7% more per degree Celsius. That's the current math. So every degree up, you click up. Every 1 degree, 2 degree, 3 degree, 7%. Then compounded to 7%. Compounded another 7%. This is better than your S&P returns, okay? So it gets wild really quick. Bigger floods, bigger droughts. Things become more volatile across the board. You also simply have, what we're talking about, oh yeah, you also simply have thermal expansion of water. So now you have sea level going up. Just because well, you also have melting of ice caps and glaciers and stuff. You know, that's, I'll touch on that in just a second. But you simply have water expanding a little bit more in volume. Its density decreases, the volume expands as the temperature increases. So most of the sea level rise that has been observed, and also we are going to have in the future, if the planet keeps warming on the trajectory that it is, will be because of the thermal expansion of water. Though, of course, as the planet gets hotter, you also have more glaciers melting, ice caps melting, and what was once freshwater locked away as ice, freshwater ice, well, now it's in the ocean. And you have overall sea levels go up. And that's what happened with the last ice age. You had multiple meltwater pulses during this time frame. The younger dry ice is a pretty big mystery. Some people think it was an impact. I'm more aligned with that camp as well. But basically, big oscillation, shift, and huge surge of volatility across Earth during the younger dry ice, 12,000+ years ago. Took us out of the ice age. Now we're in this interglacial period. But we're seeing record melting at Greenland, one of the last big repositories of ice on the planet. And we're also seeing these unusual earthquakes under Antarctica, which of course has the biggest ice sheets. So let me pull up this article for you. I hope I can get it. Yeah, we'll read this one right here. I think this is the one that I was looking at. Yeah, that's correct. Okay. So deep learning helps discover hundreds of Antarctic earthquakes coming from an unlikely location. And I'm not really going to read the whole thing, but basically Antarctica is a very interesting continent. It's surrounded almost on all sides by these divergent plate boundaries. So you have oceanic plate being created on almost all sides of Antarctica. Very unusual. And you also have you have a rift valley underneath parts of Antarctica where you have tons of volcanoes and volcanism and more, but it's all underneath the ice. Almost all the volcanoes are under the ice, so they're like Mount Erebus is above the ice. But they apply machine learning algorithms to the seismic data that they have collected in Antarctica due to a variety of seismic survey expeditions that they've done. And they were able to identify a whole new batch of earthquakes that they previously missed. So they just simply were having difficulty finding these earthquakes with normal mechanisms of finding the P wave, the S wave. This is like earthquake identification. These deployments going from 2001 to 2015. So this algorithm automatically picked these P and S wave arrivals and generated a catalog of 10,068 events. A lot of them over magnitude 5, but most of them ranging this like less than magnitude 5 range. But basically, what they saw was that they occurred in the locations that you wouldn't expect, and the theory is that it's all the pressure of this ice on the lithosphere causing these earthquakes at this boundary between the lithosphere and the asthenosphere, these intermediate depth earthquakes where you typically don't get earthquakes. You get more earthquakes that are shallow, and then you get a bit of an increase again once you go to deep focus quakes greater than 300 kilometers. But in that zone from about 150 to 300 kilometers, you typically don't get that many earthquakes. It's like a shadow zone. Well, they found a whole bunch of those earthquakes in Antarctica because of this ice pressing down on the lithosphere, just simply the weight of that ice, right? So if Antarctica starts to melt and Antarctica is warming up rapidly and things are becoming more volatile in general, right? You can imagine how that isostatic rebound is going to influence the geology, the earthquakes, and the tectonic processes of Antarctica. A classic example of this is in North America, where we had the Laurentide ice sheet. Well, now you have the Great Lakes, right? But this used to all be heavily compressed due to the massive Laurentide ice sheet. And then because of the younger dry ice and the melting of the Laurentide ice sheet, right? Huge discharges of water across North America, massive floods. And now the land is still rising and rebounding from that. There's more theories there to go into, but for now, that's what we'll talk about for isostatic rebound. But we see the effect that that can have. So as you get this redistribution of mass, and here we see Antarctica with all its mid-ocean ridge spreading centers. Look at that. All divergent plate boundary except for basically right here. And actually we got a bunch of earthquakes that pop off right in this region in 2025 in this back and forth sequence with the earthquakes that struck Kamchatka, the magnitude 8.8 being the biggest since 2011. So, you know, there's all these hidden connections. If you pay attention, you're like, oh, it gets really interesting. But yeah, we see here all this being divergent plate boundary except that one location right here. Here is this 6.6 that occurred back on the 20th, East Pacific rise, but on the Antarctic side. So a lot of glaciers are rafting off, they're melting, raising sea level, changing the mass distribution on the surface of the planet. You have big atmospheric changes that are occurring. We're already observing changes to Earth's natural resonant wobble, the Chandler wobble, and we're seeing big earthquake activity. We dropped thousands of nuclear bombs. The Earth is warming up faster than we've ever seen in the geologic records, like short some sort of cataclysmic impact event. You know, one good example of Earth warming up was the PETM 55 million years ago. I believe the rate now is about 10 times faster than it was then. So all this is to say is that the Earth is a system of change. This is, you know, these changes are going to be, they are big already, and they're probably going to get bigger. Now, I don't want to say like, okay, guys, it's time to freak out. Like everyone freak out. Change is an inherent principle of nature. And so to fear change is to basically fear reality as it is, right? You're not a kid forever. You're also not going to be old forever. Everything is just always changing. So that is the default state of reality. But it's good to know what's actually happening. That's the thing. And not just to be fed one story from one side or the other, which is only going to contain not even half of what's actually happening, right? So it's going to be very select, narrow, blinders on view of certain things. I personally want to see what is most likely to happen, right? I don't have control over the entire truth of things, right? I just hope to get as close as possible. And my responsibility, I basically see it, is to share everything that I learn with you guys, and also to clearly state, you know, what are my thoughts, what are my ideas, my speculations, give you the data, the hard facts, and then, you know, clearly label what are my ideas, my speculations, and more, but to deliver that to you and for you to make up your own mind. So we are seeing these big changes unfold. And right now in the past month, we are seeing this interesting connection between the events that have unfolded. The antipodes for these three earthquakes lining up here over South America, right over the Big Bend, right next to the epicenter location for the magnitude 6.9 that ruptured before those three earthquakes. And then also on both sides now of South America, magnitude 6.6 earthquakes like this. So we were looking at these earthquakes. In general, what you'll notice is that there are more magnitude 8 earthquakes that occur outside of the bend zone than have occurred within the bend zone. This is magnitude 8.0 up to the highest 9.5, and you see that gap right there in the bend? It's had a bit of a deficiency. And this one right there, I think, was an 8.2 in 2014. So we haven't seen a big earthquake here, magnitude 8.5 or greater, ever in the record. Now, if we go down here, obviously this is a hot spot for some reason. 9.5, 8.8, okay? So we have the 9.5 and the 8.8. Here's the 9.5. there's the 8.8. But if we go back to this map, where is it? This one right here, you'll see something interesting. Zone in on this. When the big thing happens, there will be signs, okay? You don't just go straight to a 9.5. With Japan, the 9.1, you had a foreshock for that. It was a magnitude 7.3, if I remember correct. But if you look here, we'll go to oldest first. Look at this. You have on the 21st of May, this is all universal time, 21st of May, 1960, 8.1 hit right there. Boom, okay? That's a big earthquake. You could be fooled into believing very easily that that's the big quake, okay? Well, about a day and 8 hours later, right? So like, what, 32 hours later? 7.8, just nearby. Boom, another big one. Okay, you had a double sequence. That happens. We've seen that before and at these magnitudes. Well, look at that. Just about 15 minutes later, you get your magnitude 9.5. So when the big one happens, or the big thing happens, we will have signs. There will be signs that it's coming. But we just have to be able to recognize them for what they are. And I wasn't alive back then, so I'm sure that there's things that are happening that maybe could have helped us zone in on the location. But what we're seeing right here, for example, these could be preliminary signs of effectively of, you know, and then if we start to get activity there, like we saw a 6.9 already, but let's say we get another one to hit, like high magnitude 7, that might not be it. That might be a foreshock to something bigger. And this other activity that we've been showing, and there are, you know, the waves from a high magnitude earthquake will go all the way across the globe. Let me show you that really quick. This is really cool. So, and I've shown this graphic before, but let me show you what I'm talking about. We have this visualization here thanks to the Princeton University. And so, and I'll rewind this. Here is the epicenter, boom, you get the magnitude 7.8. We see how the waves propagate across and they go to the antipode. Now the strength of them is going to be quite a bit weaker than obviously them at the source, but there is this mechanism for loading stress onto faults due to how seismic energy travels. And it's not just across the surface, it's also traveling through the interior of the Earth as well. So keep that in mind. So we are seeing, at least right now in the past 30 days, some evidence suggesting maybe this is an area to watch. But if something truly big has happened there, we will have warning signs. Now, something else that I want to mention is, and I'm not sure, I've never heard anyone talk about this, okay? And I don't know the level of significance for this, all right? But this is definitely something to know, because we've never seen anything like this in the past. This is what I was referencing earlier, okay? Here's the San Andreas Fault running through. It's been there for a very, very long time, all right? What hasn't been there for a very long time is the city of Los Angeles or San Francisco, or basically all the development of California. All that's new. That's also weight on the crust and more, though, you know, huge ice caps 2 kilometers thick is quite a bit different than, you know, your townhome, okay? But one thing that does occur is that we have these highways. We have mega highways. I just drove up to LA a couple days ago. You know, sometimes it's 8 lanes across. Look at all these highways. Millions and millions of cars driving every single day. Well, before I quit my job, I was doing seismic surveying across California. And so I can show you this data here. We'll do a little presentation on this. You have what are known as microtremors, okay? And they are at different frequencies and they kind of go all directions. But you have Microtremors caused by both industrial and cultural noise and also by the natural environment. So if you look to the top right, you see traffic, factories, sea waves. These are classic examples. The microtremors generated by the waves hitting the ocean. They have a few different resonant frequencies. They're known as microseisms for the most part, though they occupy an entire frequency band. But those are usually centered around, I believe it's 0.05 hertz and 0.5 hertz, or it might be 0.15 hertz and 0.5 hertz. Either way, they are lower frequency, and then traffic and factories and industrial noise and all that stuff are higher frequency, okay? So every single car driving by is generating noise, industrial activities generating noise, and it's just simply always going out into the earth, into what are known as microtremors. So the earth is buzzing with them from everywhere, okay? Now there's a seismic method called passive seismic that looks at these microtremors. So I did some passive seismic surveying back in the day, and I'll continue doing this. You know, I'm a young guy, I can plenty of time, hopefully. But what I found was that when you are using these natural, or just these microtremors in general, to characterize the subsurface, using what's known as multi-channel analysis of surface waves, if you're in a natural environment, you get really high quality data. Whereas if you are in a noisy urban environment, the data really is quite a bit worse. And so I kind of made that discovery. I'm sure other people notice it too, but in general, when you're learning about multi-channel analysis of surface waves and passive seismic methodologies, a lot of times they actually tell you to go near the highway or the road so there's sufficient noise for your data collection. Whereas when I did 100+ surveys across my hometown, anytime I set up basically near a big thoroughfare with tons of noise, anthropogenic noise, the data did not come out as well. So I was like, okay, something's weird here. And I just put this together in my head about how all this anthropogenic noise from cars and industry and more could be affecting faults, because they get loaded with strain. All these sound waves technically are loading incrementally stress and strain upon a fault. Now, back in 1906 for San Francisco, really wasn't a concern. Fort Tejon, 1857, you didn't have highways and cars and all this crazy stuff. It was almost nothing in California, right? You didn't have these influences back then. They both topped out around 7.9, big earthquakes. Now you have this. Now you have this influence. So there's a variety of ways you can collect passive seismic data, which is where you get basically seismographs and geophones. They're measuring the vibrations of the earth. They're very sensitive. And there's different survey geometries. So you can put them out in a line. You can put them out in an L shape, a triangle, a circle. These are the standard survey geometries that people use for a long time. I started to have the idea of using a Fibonacci survey geometry, and you can see that right here. So I thought, well, you know, using clever survey practices and some pretty simple math, because the Fibonacci sequence, which converges upon the golden ratio, which we see, you know, manifested all across the universe in aesthetics, it's not that hard to do. 1 + 1 + 2, you know, so it's 2, 3, 5, 8, 13, 21, 55, 89, 144, boom, 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 going on. So using these nodal seismographs, I created this Fibonacci array, and I also created the line, the L shape, the circle, the triangle, all the same location, same day, same conditions, and the Fibonacci array came out with by far the highest quality data. Here we can see that data. And specifically, you see the dispersion curve to the right. So this is super high quality. You have, what we're looking at here is frequency and the phase velocity, and then we see our frequency here, okay? So this is the velocity of the wave, and then at what specific frequency. So we see that the velocity increases at these lower frequencies and then decreases down here. but you see this beautiful, beautiful dispersion curve. And when I showed my mentor this, he was like, this is one of the nicest dispersion curves I've ever seen in my life. And he's done thousands of these all across the world, these surveys. So he's like, something, and he helped collect this data. We did the whole thing together. It was me and my mentor and a friend of mine. And so we collected all of them and compared them. Well, I have another one here, which is, let's see what it is. There it is. Here is another one from the survey that I did, like 100+ surveys. This one is located in a very noisy location. And you can see that you get all this noise here, right? It's hard to find that clean dispersion curve, which is indicative of the geology, right? You're looking at different bedrock layers, soil layers, and more. That's what we're identifying here. So we see in this location that's quite noisy, and I can show you that on the map. We go back here. Here is the location of all these surveys that I did, my hometown, Napa right here. N82, we see it right there along the highway, but more important than just that, it's also in the middle of all this stuff. You know, you have these markets here, and there's just a lot happening in this area. And there's other examples I could show you. But if I go back, here you see dispersion curve for that location, you see all this high frequency noise. So the download I got a few days ago was all this noise, this energy, these seismic waves are loading onto these faults. How significant of an effect that is, I do not know. Attenuation does exist, but that's how attenuation exists, because it disperses and gets absorbed. So is it orders of magnitude less than the natural strain accumulation rate for, let's say, the San Andreas? Which we can just kind of guess, estimate about 0.1 kilopascals per year, let's just say. I mean, that's like a kind of an average accumulation rate for a fault, but it could be different for the San Andreas. It almost certainly is, but it's not going to be 2 orders of magnitude different. Is it 2 orders of magnitude less than that? Is it like insignificant, or is it significant? That I do not know. But as it relates to the Earth and these faults, never before have we had all this noise get generated anthropogenically. And so these faults are getting loaded and loaded and loaded. And I just kind of have the intuition, again, do your own research, make up your own mind, but I have the intuition that we probably now have the potential for larger events because we can have more strain accumulate on them. And look, California has these bends on them, right? So when you get these bends, you get things locked and gunked up. So I think what we're going to see is events that are going to take people by surprise. The big one finally hits California. Who knows when it's going to happen? But when it does, maybe it's 0.3 magnitudes higher than even the highest estimates were for that part of the fault, right? And no one took this into account. I at least have never heard anyone talk about anthropogenic noise from industry, cars, and everything, and the influence on big earthquakes. Maybe I hope there's other people have talked about it. I haven't heard it. So like that's a factor. Now another factor which we can look at is we talked about the atmosphere. Well, right now NOAA has officially declared that El Nino is here, and it's actually happening really quickly. And in fact, this is one of the strongest El Ninos ever observed. So what many people are calling a super El Nino, and I think that is a fitting description for this. A great El Nino, a super El Nino, Godzilla El Nino, whatever. It's a huge El Nino. An El Nino is basically a big change and shift in Earth's temperature, atmospheric circulation, and more. So here we see the subsurface water temperature for this band here, not only moving to the east towards South America, but it's also increasing and getting closer and closer to the surface. Now, if we look at this other graphic here, we can see it literally play out. Here's South America. We also have very hot water off the coast of Mexico, California, but we see El Nino is forming. We've seen this many times before, but this is going to alter weather patterns, circulation patterns for rainfall, and that's, changing the distribution of mass. Water is very, very fluid. When you have the new moon or full moon, the tides are higher. We just had king tides. I talked about how king tides, we were likely to see some faults break and everything as a result of the king tides. And well, we had Indonesia and we had China pop off. And now we have the 6.6 that struck the mid-Atlantic. So all these things are super interconnected together, and mainstream science is just starting to put the Lego pieces together, because science, as we know it nowadays in the modern world, is inherently divisory, okay? So it's not the science, the natural philosophical science of Leonardo or Galileo or Copernicus or of the Greeks. It's like slice, dissect, examine, microscope, get everything out of the picture that's no longer, that we think doesn't apply, or, it's very reductionist. Whereas, of course, the universe acts from a holistic perspective because, well, the universe is the universe, right? God is everything. So, yeah, sure, you can like split apart the different frequencies of God, just as we're all individual human beings, but we also have the full expression of God within us. That's the whole story of Jesus Christ, or of, let's say, Muhammad, or Buddha, or whatever. This isn't turning into a religious discussion. I'm not saying what's better than the other. I'm more of a spiritual person, finding the underlying truths behind all this. But we know that universally, and Marcus Aurelius talks about this. Roman Emperor. I'm reading his book Meditations right now. So this goes back so far, people. Like they've purposely have blocked a lot of this from the knowledge, the education system, or they're specifically, distracting people from the truth of things. Now, a good example of this, I'm only going to show this for like a second because this honestly kind of makes me sick. Kind of makes me a little nauseous, but this just proves my point very clearly. Okay? And hey, you have your own thoughts, okay? It's fine. But, we have this comment that was, or this post that was done by the world's first trillionaire now. Make our sun sentient to understand the universe and extend the light of consciousness to the stars. And this guy, by the way, does not believe in self-reflection. He never self-reflects. He stated that multiple times. So what a combo that is. The arrogance, right? That our sun isn't conscious and that the universe isn't conscious. And only consciousness resides in humans somehow, but we're also insignificant. And it's our job, or maybe it's this guy's job specifically, to spread consciousness among the stars. He can do it. No one else can. The sun isn't conscious. It's just, it's really, the arrogance is crazy. Because of course the sun is conscious, right? The sun is responsible for all life on this planet. The earth is conscious. The earth is responsible for all life on this planet. You are from the earth and you will return to the earth, right? And you may just be able to hold on to a little bit of plasma energy to your Merkaba to fly around somewhere else with after death, right? But it's all springing from this source. The earth is this constant place of change, right? A tomato ripens on the vine, falls to the ground, decays, becomes soil, and then somehow springs up into a caterpillar, then a butterfly 2 years later. It's miraculous. So change is the constant. And we are a part of that. And how is it that matter and energy and everything, when it manifests into humans, becomes conscious, but no other animal is conscious, right? No other thing is conscious. It's only humans. And we're the only things, the 7 or 8, whatever billion of us, and the whole rest of the universe isn't conscious. It makes zero sense. The ignorance and the arrogance, the two of them, it's really disturbing. So that's one aspect of society that we live in right now, right? And there's all these other little things that you could look at, deceptions that are put out there that if you just kind of like buy into it, you're disconnecting yourself from the truth of reality. They'll tell you that the sun isn't connected to the earth, doesn't influence the climate, right? They'll tell you that the sun doesn't influence Earth's geology. Well, you have these orbital cycles, and you have Earth's orbital eccentricity changing. When the Earth gets closer to the Earth, we're receiving a ton more light and radiation, and you have all that influencing ice age cycles. These are Milankovitch cycles. There's untold ways. We only know a fraction of a percent of, you know, like all the reality that exists. Our knowledge is, I can't even put it into words. It's so minuscule as to be, it's probably 1 grain of sand on all the beaches of this planet is what we know compared to what exists. So when we do learn a couple things, we should be pretty happy for that, and we should cherish that and, you know, spread that information out there, because the connections, it's like a synapse in the brain. Every single neural connection helps others form, and you get these new downloads, which is why I've researched into all these different fields, and many of you are as well, and that's why you like the channel, or whoever. Maybe you're total random. You're like, hey, I like this. That's cool. If you don't resonate, you know, go find something else to watch. That's fine. You don't have to stay here. But since we're all connected to this, when we find these universal truths and we connect to them, there's an instant resonance of knowing. There's an instant resonance of knowing. So there is, you know, regular science, you could say, coming out showing the connection between the sun and earthquakes, between the sun and volcanic activity, between the moon and earthquake activity, between the moon and volcanic activity, between the planets and solar activity, and between all these things. Like it's all starting to come together, and in 50 years hopefully we'll have 2 grains of sand that we can rub together to display our knowledge of what actually is on this planet, and hopefully it'll be a lot better. But we hope that the sun extends its consciousness to us. That's what I at least hope for. I think the sun is very happy and very benevolent to us, but it also for sure could send us back to the Stone Age. 1 super flare and all those Starlinks are gone, baby. I mean, that's probably, we don't know. It's going to be big. If we get a real super flare, like a real super flare, 10, 100 times stronger than the Carrington event, technology is probably gone. Now maybe like your little, it depends on, because there's this induction effect that occurs. But for smaller technology to get fried, it needs to be very high frequency. And we don't know what a super flare, the plasma and everything it's going to contain. We don't know if it's going to knock out small electronics and big electronics and power grids and satellites and more, or whether it's just going to affect the big systems. Regardless, it'll be big. It'll be unprecedented. Hasn't happened in modern times. How does that affect the rotation, the spin of the Earth and earthquake activity? Massive amount of energy and plasma loaded into the Earth, right? Big earthquakes, probably big volcanoes. We see this synchronization between really big volcanic events and changes to Earth's magnetic field. Now, right now, we are seeing changes to Earth's magnetic field. The South Atlantic anomaly is getting bigger. It's also reducing strength. We do have the magnetic pole in the northern hemisphere moving quite rapidly, about 40 kilometers per second from Canada to Siberia. You don't have the magnetic pole in the southern hemisphere moving all that much. It's moving about 10 kilometers per year. But, and actually I can pull this up. I have a really amazing Google Earth project for Earth's magnetic field. And I don't show this that often, but it's really well fleshed out. So let me show you this. This is pretty cool. So here we go. So we are seeing changes with Earth's magnetic field. Here's the flux slope over Siberia. Here's where the magnetic field is going. It has started to deaccelerate. This is the magnetic pole. The magnetic field is not defined just by the pole locations. It is moving right towards this ancient supervolcano that exploded with one of the biggest ever identified eruptions 1.1 million years ago. This is Gokul Ridge. Very interesting thing. I've talked about this before. But if we go down here to South America, we see how fast it's moving. It's moving quite slowly. The difference is that if we go here, we see that the magnetic pole in the southern hemisphere is already quite a bit offset from true south pole, that rotation spin axis. Whereas if you go up to the northern hemisphere, the magnetic pole, even though it's rapidly moving right now, it's actually located quite close to that rotation spin axis. So, we are seeing changes with the magnetic field, but we're not necessarily seeing anything that suggests something imminent is occurring. Thankfully, the magnetic field of all the things seems to be the most normal. It's still relatively strong geologically, protecting us from space weather impacts and more. So we're happy, we're happy that the magnetic field is still relatively strong, and it appears that it's mostly moving. The magnetic pole in the northern hemisphere is moving to this flux lobe over Siberia, and that for South America, which I'm not showing, the South Atlantic anomaly, but that's primarily related to a patch of reverse flux emerging from the mantle and the inner core boundary out to the Earth. Eventually that'll go away because we see these examples of these flux patches emerging from the interior of the Earth and altering the magnetic field in that local location and then going away. We had a huge positive flux lobe. So the field strength got stronger over Western Europe, like 700, 800 AD. We saw that happen for the Levant, back around, I think, 3000 AD, or it's 1000 AD. It's one of the two. We saw that happen for Hawaii and for Japan in the past 1,000 years, and also for Mesoamerica. So we know that you can have these positive magnetic flux lobes push out, and then they basically dissipate, and the magnetic field strength returns to the global normal for that location. We hope that this South Atlantic anomaly is pushing out is just a reverse flux lobe doing the same thing. So I'm personally not concerned about the magnetic field. It's like the one thing that seems to be fairly normal on our planet. But what we do see is that there is this synchronization between big volcanic activity and, well, changes in Earth's magnetic field. The last reversal, 780,000 years ago, was obviously a big event because you saw the flip. Well, 760,000 years ago is when Yellowstone last erupted in a big event. Only 20,000 years in between, okay? But that is 20,000 years. But we see other volcanoes synchronized with it. Marsilli volcano here synchronized with magnetic reversals over the past 2 million years. That's quite interesting. There's a lot more data that are presented more, but I think you get the idea. So all these changes are coming together. We're seeing big changes to the atmosphere due to anthropogenic forcing through the combustion of hydrocarbons, simply the release of energy, holding more of that energy in. We're having super El Ninos. We're having unprecedented changes for our limited data set, right? Very limited data sets, not millions of years that we have this. It's like 150 years, but we are seeing in that small time frame unprecedented changes to the wobble of the Earth, the Chandler wobble. It is starting to come back. Big earthquake activity. We detonated thousands of nuclear bombs. I mean, there's a lot happening, okay? A lot happening. So I wanted to give you that update. I think that basically covers everything I wanted to discuss. Now would be a good time for us to do a question and answer. So if you have a question, please ask it in the chat. We'll take some from the general chat. We'll also do super thanks. Okay, so I think we've had some super thanks come through, yeah. But we'll also take some questions from the general audience, and we'll go back and forth. So I'll take some from the general audience at the beginning, and then I will go to the super thanks questions. If you want your question answered, attach it to a super thanks. That is your way to guarantee an answer. We have a lot of people watching right now. Thank you all for being here. Again, I'm your host, Stefan Burns. Cosmic Bro. You're Cosmic Bro, helping you understand what's happening to the best of my ability. N=1. I'm one human. I do the work of hopefully many. I don't hold back. But yeah, so thank you, Faith, for the for the kind words. Thank you. And clearly Brooke is asking, did you discuss California in detail in terms of when an earthquake could potentially hit? I already have some videos on California for you to watch. In particular, there's two. There's one that tracks there's actually a few, but the most recent one will have a thumbnail saying California is tearing apart, and I go quite in depth as to the recent tectonic activity in California. That's the one to watch to start, but I would also watch my video of 1811, 1812, which is further back, and then I think I have like another video or two. I actually have quite a lot on California, but there's another big one that's like almost an hour long, like the others. So if you just go to my YouTube channel and search my channel for California, it should pop right up. All this should pop right up. And this is off topic, but all I do is wash my hair with Desert Essence, which is a really good natural shampoo. I use their conditioner. I rinse it with spring water with a little bit of vinegar in there for the scalp, the pH balance. And then after I rinse it and kind of pat it dry, I add a little bit of aloe vera juice. That also has a low pH, around 4.5. But it's just juice. It's not like all these chemicals and stuff. It's literally just cold pressed aloe vera juice. Let that dry, and then I just comb my hair every morning. I don't put on any product or anything. There you go. It's really simple. But it's about hair training. Hair training is a whole thing. I used to have my hair really long. It helps you train it, and then it's a whole process. And you have to obviously have good hair. But I think some things with hair, and I'll be done soon. But I think, a lot of people are constantly shaving their head. Hair doesn't like to, it's like a lawn. If you're constantly mowing it down to the ground, it's not going to grow, baby. So you got to let there be some growth. Now you also need to keep it clean. You got to mow the lawn every now and then, but move the blades up. Keep at setting 4, not setting 1, right? So yeah, it's pretty simple stuff. It's pretty simple. Do you have a prediction of when the big one in Southern California may hit? I heard we were overdue. Yeah, I mean, and that's kind of what the earlier person was asking, but here's what I can say, because California is probably the hardest location in terms of like really seeing when an earthquake's going to go off, because they're so like few and infrequent, and the fault system is very bizarre. It's easier to forecast earthquake activity in other locations in California, but the longer, this is very simple, and you guys already know this, but the longer a big one doesn't happen, the bigger it's going to be. Okay, so you almost kind of want to happen to get it over with. Last big one to strike San Diego, that area, 1800. Then you had some big ones in Los Angeles. Like, I'm talking magnitude 7 plus earthquakes, okay? Not magnitude 6. Those can be big. I'm talking magnitude 7 plus. Then we had two mid-magnitude 7s in 1812 for California. You have Fort Tejon, 1857, magnitude 7.9, they estimate. You have San Francisco, 1906, magnitude 7.9. You have magnitude 7s at the triple point up north, and you had Ridgecrest in 2019, but that's like Mojave. That's the East California seismic zone and places like that. You're talking about Southern California. It's super overdue. Garlock Fault is super overdue. Hundreds of years. They can have magnitude 7.5 based on the current estimate. That could be more. Again, like I said, all these roads and highways and industrial noise. I don't know how it's affecting these faults, but it's certainly unprecedented geologically to have all that anthropogenic noise there. It's also unprecedented to have all this anthropogenic warming, and then this modern maximum of solar activity helping the heat output and the light output of the sun be retained by the earth. That's the bigger thing. This thing's nonstop pumping out energy. 1,362 watts per square meter nonstop, right? That only changes with our orbit, and right now our orbit's actually pretty circular. It's not a perfect circle, but it's actually tending to get closer and closer to a perfect circle. We're not expanding our eccentricity orbitally going forward. Eventually that will, but not right now. Right now it's actually getting closer and closer to being a perfect circle. So we're getting consistent solar radiation, and we're holding on to more and more and more of it because of what's happening with our atmosphere, of which we've played a big part, because we've unlocked millions of years of solar activity and hydrocarbons and all this stuff. So it's crazy. It's really crazy. I don't know what's next. I really just don't know I don't know what's next, but I'm just laying out all the different things that are happening. Another good one, like you can't discount these little things. I don't know why people are so quick to dismiss little things, especially when there's a bunch of them, they add up. Concrete, asphalt, they hold in heat way differently than like grass. For California, for example, before the introduction of European grasses, you had native plants that stayed green throughout the summer and kept water close to the surface. You had better water tables, stronger aquifers, right? And when you have plants at night, they respire water up into the near surface, like that first foot or two above the surface. That totally changes the dynamics across the board for the hydrological cycle. Well, Europeans brought in these grasses that turn yellow and just basically die during the summer. Then you can have these fires. And we put on a whole bunch of concrete and asphalt over the earth, changing, and also a lot of dirt is just barren now, and that's affecting the albedo and heat radiation and solar absorption and everything, right? So it's crazy, but all these little things matter. Now, how much is that one particular thing? Like, can someone do a study analyzing concrete land surface area compared to pre-industrial times and get some sort of percentage increase number, whatever, statistical for it? Like, I guess some genius could do it, but I would almost think those results are going to be meaningless because there's so many confounding variables. How are you going to isolate the signal from the noise? But if you just like, just kind of step back and look at the thing and be like, oh wow, there's that. There's how we've like dammed up Hetchetze and all these other things. Think of that. All the dams we put in around California, right? The changing water mass over the landscape, how that's influencing the faults. No one talks about that because A, most people don't know, and B, those that probably do know probably don't want to like, spook people. We see all this examples across time of, oh, don't tell them this because they may freak out even though like something bad is about to happen. It's wild. It's wild stuff. When they're dropping these secret nuclear bombs, they weren't telling the public. So we're going to get to some of these super thanks questions. $2, thank you for the super thanks. Chandra, thank you for the super thanks. I've not seen the movie. My one friend who watched it, you guys know her, Dana Kipple. She liked it, but I haven't seen it. I'm not going to go see it either. I'm not too into it. Dandelion Dana, speaking of Dana, thank you for doing your best connecting all the cosmic dots for us. It's so refreshing. Also, I really want to be your hairdresser. All right, well, thank you for the super thanks. And if you catch me on the street, you can do it. I'm not going to say no. Lone Wolf, thank you for the super thanks. Yeah, I'm going full Super Saiyan. I just need to turn it blonde now. Then we got it. Thanks for that. Tamara, Spencer, hope you're doing well. Sending you lots of love and thanks. Thank you as well. And Missy Alpha Queen B, appreciate your research you do and how you explain it. Thank you so much for the super thanks. Much appreciated. Fake account 333. Everything everywhere happening all at once. Dormant volcanoes, faults, cracks opening in Indonesia while the Alps shake. Rivers are drying up. Could this be Earth crust displacement starting? So really simply, because this is a whole rabbit hole I don't want to get lost in. Earth crust displacement, and I don't want to call it theory because it's not theory. It's a hypothesis, it's unproven. So therefore it's a hypothesis, an idea. Is that the entire crust of the Earth can somehow simultaneously disconnect from the other layers of the lithosphere, like the asthenosphere, or even let's say the asthenosphere sticks around the mantle, which is more malleable, and shift, and everything just shifts. Well, we know that the crust moves because we have earthquakes, right? You can literally see sometimes the land masses next to each other grind past each other. A great example of that was the magnitude 7.7 in Burma, Myanmar. So I think I have that in my slides here. Let me see if I can pull it up. We have that fault. Yeah, here it is. This is crazy. Yo, check this out. Here we have, and okay, so, well, you're going to want to watch this area right here, okay? So let me turn this on again. you'll see it start to shake, and then you'll see the land move past past itself. Okay, getting close. Watch, 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 watch. Boom. This is the first ever example that we've seen. This is what was reported on back in 2025. The first clear example of land moving, sliding past each other from the earthquake on the fault plane. So again, very clearly, watch this right there. Boom. And you see the cracks form. Crazy. So obviously, you can have displacement of the land, but can you have it for the entire Earth? I don't think so. So is that Earth displacement starting up? I mean, I can't definitively say no, but I don't think so. I don't think that's geologically possible. And there's really not much evidence to support it at all. There's a lot of made-up evidence, okay? And if you don't know the science, it's easy to be fooled because it's made-up evidence. But if you don't know the terms and the stuff, right, you're like, oh. But it's made up, a lot of made-up stuff. $2 Willis, thank you for the super thanks. Yeah, this is a strike slip earthquake that struck the mid-Atlantic, so no tsunami. You could technically, I guess, if you're just talking in general terms, have some sort of big landslide in the Atlantic off one of the ridges, if we kind of look at this. But you would need it to be big. I don't know where this would happen for you to get a big landslide to then hit the eastern USA. So it have to be like up here. And I don't think there's any evidence of there being tsunamis really hitting the East Coast. But I'll look into that. But yeah, probably not something to worry about. Worry about the cyclones if you're going to worry. Tsunamis hitting the East USA. Now you could have, there's been big earthquakes off Portugal and Spain, the Iberian Peninsula. It's possible that you could have something radiate out from like this area. But that's probably about it. Or you could have something in this zone here, maybe shoot up that way. It's not on my top list of, yeah, interesting thing about Stoicism. Thank you for the super thanks. Agree, it's important philosophy. Heather, thank you for the super sticker. And Geraldine, your rant about the ignorance was cracking me up. Well, I'm glad that you laughed from it because laughter is good for the spirit and for the soul. So you help to remediate some of these energies. So thank you for your deep belly laughs. That's great. And then Candace, thank you for the super thanks. Will the sun go micronova in the 2040s due to it being impacted by the galactic current sheet? Like we know that there are different electromagnetic dynamics of not only interplanetary space like the heliosphere, but also interstellar space. And therefore that stands to reason of the galaxy as a whole and also extragalactic space. So multiple galaxies, galactic clusters and more. But show me the data for a galactic current sheet. Doesn't exist. It's another one of these things that's made up. Now, are there going to be flows and currents and everything in the galactic environment? Sure. But in terms of accurately identifying some galactic current sheet and saying that's going to cause the sun to do this thing that the sun also isn't known to do, like a micronova is a specific term for a certain type of star, which our star is not. This is where the idea is that the entire corona of the sun explodes off all in one go. I'm not saying the sun can't do crazy stuff. I think the sun has done a lot of crazy things. But it's basically, there's a few people that talk about this, but basically it's the plot of 2012, which came out in 2009. And then these people started talking about this after 2009. So they watched the movie 2012, and then they basically took these ideas and turned it into a fear-mongering YouTube channel. So I would bet no. I think we'll all be fine. Doesn't mean that we can't have big solar events, big earthquakes, big volcanoes. Like I just laid out this whole thing about how we're going through unprecedented changes in many aspects, right? Earth electrification, all that's happening. But some of these other things are more fantasy than real. Like I want to stay grounded in reality rather than these fantastical things that don't have any real data supporting them. So thank you for your super thanks. Kareen, again, or a different Kareen maybe. Thank you. Just watch. I'm not really sure what you're saying with your second sentence there. But what, maybe you're saying like your live stream or something, resonates and jives with the prophecies of Gaia stopping to feed humanity and for us to wake up. Buckle up, buttercups, we're in it. Yeah, I mean, we should all be prepared for natural disasters, basically, right? Don't take anything for granted, but enjoy, live your life. That's always been my thing. You know, don't live your life in fear. And a quote from Marcus Aurelius is that there's no point in really worrying about the future because all you have is the present moment. That's true. All you have is the present moment. And there's no point in worrying about the future because at the worst case, you'll approach the future, which is the next second, but you'll approach the future with the same consciousness and mental capability that you have right now. So ideally, you continue to improve yourself and therefore you approach the future with even better resources and capabilities that can probably solve the problem that you may be worrying about in the present moment. So wise words from Marcus Aurelius. Dad RVM, thank you for the super thanks again. Amanda, talk about the difference in plates for California subduction versus shifting, hitting plate faults. Big difference in results. Well, California doesn't really have subduction too much anymore. The subduction zone got eaten up. It's now a transform boundary. But there are different boundaries. You have where the plates are sliding past each other. You have divergent boundaries where you have active plate creation. This is a mid-ocean ridge. And then you have convergent plate boundaries where you have subduction. And you have subduction here in Cascadia. You have this fault there subducting underneath the northwestern part of the United States, Oregon, Washington, and British Columbia, Vancouver Island, etc. But the subduction that used to occur off the coast of California now has been transformed into a transform boundary. So yeah, big difference in earthquake magnitudes. The typical largest earthquakes you'll get on a transform boundary, like California, is magnitude 8. But now with some of these other factors, I think it could perhaps be higher, but we don't know. We're only going to know until we find out directly, which we don't want, but it's going to happen inevitably. Your thoughts on the idea that some oil on Earth is abiogenic and comes from the mantle itself? Is that theory plausible to you? Well, not really. Well, I'll say this. We haven't really drilled that deep into the Earth, so we really don't know. But one clue, this isn't directly disproving it, but one clue is that these people that talk about abiogenic oil from the mantle or whatever, just naturally replenishing, they're always fooling you with some fake video of like a sewage line or something that's like spewing out. They're like, see, it's just gushing out. It's all natural. It's like, no, they hit like a sewer line, bro. So the people that post these claims often use fake videos or AI to support them. So when I start to see that personally, I start to like, okay, what's the deal here? I want to see real hard data. There's mineralogical transitions that occur as you go down with depth, and so you're seeing diamonds produced in the deep earth, right? That's because there's so much temperature and pressure, it crystallizes the carbon into diamonds. I don't think oil is coming out from the deep earth. We have tremendous evidence that it's from sequestered carbon from plant matter and more like marshes and swamps, etc. So it's not really plausible, but I'm not going to just immediately say no, but I think you get what I'm getting to. Thank you, Clearly Brooke. And Boofhead, thank you for the big super thanks. Much appreciated. Really awesome. You didn't ask a question, but thank you so much for that. And Jay Sims, thank you for the super thanks. What do you think about the Rose Canyon fault line? Yeah, that's in San Diego, right here. I actually just learned about this recently. I need to do more research, basically. I don't know much about Rose Canyon. Last time it had a big rupture, etc. It's not that big of a fault, but I think that's probably what you're talking about. But I do know that it's a lot of unconsolidated sediments in this area. So if we do get an earthquake on Rose Canyon, depending on the magnitude, could be a big deal. And also you have a lot of homes here which are built on basically nothing. Like these cliffs are eroding actively. And you're going to get for sure, let's say Rose Canyon has a magnitude 5.5, magnitude 6. I don't know if that's possible. Let's just say it is, right? You're going to get some houses falling down. Because they, in their arrogance, built directly on these cliffs, which are literally falling apart. Like you could go out there with a pickaxe and in one night make a dent. So it would be bad news bears for sure. And then Corey was actually talking about the movie Interstellar. So that makes a little bit more sense now. But we'll continue moving on. Thank you for the follow-up super thanks. And the Milky Way is flying through space at 1 million miles per hour. Relax. Yeah, you know, everything's relative in its motion. I don't know the specific stat for the Milky Way. That's what you're saying. I don't necessarily don't believe you, but you know, how do we even measure that? That's a different story. But yeah, there's all this relative motion and movement. It's interesting. We'll do a couple more super thanks from the regular chat, and then I will sign off because we're already at nearly 2 hours for this live stream here, so it's a long one today. I hope so. I mean, I can't say I'm perfect, that's for sure. But a lot of them are pretty obvious. But you know, really requires you to just put distance. I think with identifying things for what they are, or at least closer to the truth, it requires a little bit of distance. If you form this attachment to something, then it clouds your mind, right? Like Yoda, he's sitting there, he's meditating for 800 years. He doesn't have a cloudy mind, like a cloud in mind. Like he sees things clearly. But if you want aliens to arrive in a spaceship, then you're going to look at the whole UFO, UAP disclosure thing as probably being true because they're telling you that there are UFOs and spaceships and things of that nature flying around. Now, I'm not saying there aren't aliens, but I personally, I don't know what to think in that regard. But I think there's maybe other explanations as well. Or it's a whole combo factor. But there are certainly a lot of bad actors in that field. That's just one example. Certainly, there's tons of people out there who are lying to you about, oh, I saw this thing, and buy my book, or whatever. It's crazy. So, but if you want it to be true, then you're going to believe in, then you'll kind of just like gobble it up. So you got to like just not have attachment to things. Let go. You know, the Buddha, so smart. That's kind of the way. Yeah, and here's a comment from Mona. Hydrocarbons cannot exist above a certain heat. They'll be carbonized. Kirill, hope I pronounced your name correctly. Global warming, aka climate change. Please tell me how you will change the next ice age. You can't. It's in Earth's cycles. Yeah, those are orbital cycles. So yeah, we're not changing the orbital cycles of the Earth, that's for sure. When this interglacial period ends and when the next glacial period begins is unknown. And we can certainly, there are other ways to influence Earth's climate, not just orbital cycles, but that is certainly a very powerful top-down force that we will eventually be encountering that will shift us to cooler temperatures. But this doesn't have to be 10 years from now. This is like geologic time, folks. So thousands of years is what we're talking about. And NT Gangster, what does Stefan know about the red dwarf Bernadilli Bernstein? Well, I think you're referencing the comet. This is UN 271. It's not a red dwarf. I can pull it up here for you. Oh, well, it looks like my, oh, there we go. Okay, so we can type in UN 271, the sky, live. We can look at this. This is the largest ever comet found. And now maybe Bernadilli and Bernstein found other things, but I think you're probably talking about the largest ever comet found, which we can see right here. So here we see this comet. It's directly below the inner solar system, by the way, right now. It's over 100 kilometers across. And it comes to its perihelion right around 2032. Right here. Then it's along the ecliptic plane, 2033. And we actually have some pretty crazy planetary geometry around that time frame. So it's a big comet. We see interesting things happen with comets, the sun, and more. 3i Atlas being good proof of that. Very bizarre. Tons of solar activity launched towards it back in October, November, and other weird things. But that's about all I can say on Bernadilli Bernstein UN 271 at this moment in time. I'm going to take one more question. I'll take two because this is a simple one. I try to only wear natural fiber clothes. It's really good for you, much better than like polyester and stuff, microplastics, endocrine disruptors and everything. They keep you cool. This is linen. This is a nice linen shirt from Italy. You know, actually I bought this in Malta, but I think it's still Italian. But I can't say I only wear them, but I definitely go on my way 90% of the time I'm wearing them. So, yeah. Take one final question. Well, maybe I'll finish with this comment because I think it's pretty on point. The same person will say that there's a group controlling the weather, but they'll also say that climate change by humans isn't real. Yeah, it's really quite funny when, see, that's the thing. It's not that hard to identify some of these ridiculous things. All you have to do is like have a memory better than a goldfish, basically. And they've been found to have actually okay memories. Right? People thought goldfish were stupid until some Japanese guy actually bothered to set up an experiment, and he was like, oh, they can actually remember. So, you know, never underestimate the universe, basically. Never underestimate the universe. Never underestimate yourself. It's a wonderful, beautiful world that we live in. Go out there, enjoy it every single day. Big changes are happening. They're unfolding. That is going to be what happens. You can, you know, choose to change your lifestyle to maybe lessen your karmic input into that if you so choose. I don't think that's a bad idea. You know, planting a garden or even trees where you can, guerrilla gardening. These are all good things. Reducing your consumption of oil and gas. If you have a home, maybe installing some solar, right? It's all very cost effective now. We should be doing all these things to the best of our ability and be helping others in our community. Obviously, being a good person takes some work, but it's good soul-fulfilling work. And ultimately, it's easier than being, let's say, a bad person, and then you're suffering in the hospital and no one's there to help support you. You're certainly going to feel the weight of it then. So we're here together in this community. I hope you follow along, whether you just watch the videos or ideally you subscribe as well. It helps the channel grow. You know, click that thumbs up button, smash it if you want. That also helps get this video out to more people. bringing these balanced, multidisciplinary perspectives to others. At least I think I do a fairly good job at walking that middle path, seeing things at least a little bit more clearly for what they are, trying to bring in bigger, more holistically grounded truths for you all, doing my best to research it all from these open perspectives. I look at the zany, crazy ideas, the conspiracy theories. I also read the regular research, the mainstream stuff. I'm really just interested in what's actually happening. That's my main agenda, is just to understand the Earth. For some reason, I have this crazy curiosity about the Earth, the Sun, the planets, and more. So, yes, sending you all lots of love and light. Please take care of yourselves. I'll see you all in the next video.